Welcome everybody to this webinar. The title of the webinar is XR and how it is reshaping the industrial training landscape. This is John Soldatos. I'm from company Innovax and the XR 5.0 project. And together with other European projects, we have created this cluster where we usually organize events like this webinar on different thematic topics of extended reality, technology, metaverse, and similar topics. Our first webinar was 2 months ago, approximately. It was on the convergence of AI and extended reality. Today, we focus on industrial training. I just want to share the agenda for today's event. As you are going to see, we have some excellent speakers from different projects that are going to cover quite different aspects of XR training, from what the industrial users want from a proper XR training, and how it can be leveraged in different industrial areas like robotics or space astronaut training and more. So without any further ado, just to remind you some housekeeping rules. First, the webinar is recorded. Second, I will ask everybody to mute their microphones unless speaking, so only the speakers will have the possibility to have the microphones open when they speak. Each slot is 20 minutes approximately. I would advise the speakers, if possible, to keep this 18 minutes and give some room for questions. Of course, I'll invite everybody to ask questions in the chat, to ask questions after the end of every presentation, and also we will have some possibility to discuss some issues in the end. So without any further ado, I would like to give the floor to our first speaker, Alexander, from the OpenVerse project. So please, Alexander, the floor is yours. Take your time to properly introduce yourself, your project, and deliver your presentation. Thank you very much.
Thank you, John, for the introduction. Yes, my name is Alexander Purkiewicz. I am affiliated with Vrije University Brussels and the robotics department. We are also, as a research group, taking part in the OpenVerse project, where we will be delivering a robotics use case demonstrator to show that virtual worlds and metaverse not only can be associated with entertainment and gaming, but also with industrial applications and industrial field. So today, though, I will be talking about XR enhanced training in industrial applications for collaborative robotics. And first, let me start with the current practices. So right now, mostly the methods of training in industry are either person-to-person with qualified instructors, but also skilled and experienced workers, which is the reality of many workplaces. There is also online self-study programs, text instructions and manuals, or training videos. And the issues with what we currently have in industry are that first, there is a shortage of qualified instructors. And that's why experienced and skilled workers take over the task in some part. But this again requires them to be redirected away from their tasks. The training is also inconsistent because it depends heavily on the worker, especially when it's the workers giving the training, and it is not agnostic to the person giving the training. So aside from the transfer of knowledge, there can also be a transfer of personal habits and routines as well. Also, what is very important, it lacks hands-on practice. So the employees learn from text documents or videos. They are removed from the actual environment where they will perform the job. And this results in higher stress levels when they enter the field, and also higher error rates, especially in the beginning. The training is often deemed insufficient, too short by the employees, which then causes problems in employee retention. As we know, there is a shortage of blue-collar workers in Europe, but also simultaneously, multiple countries across Europe are facing an influx in migration rates. So these two issues combined make create a need for early inclusion in the workforce of the migrants. But this, however, with traditional training, creates a problem of a language barrier and exclusion. So the non-native speakers often have no access to training in their language, and it slows down or even prevents the inclusion of potential workforce into the field. And following on that, I would like to focus a bit more on industrial manufacturing and assembly. So this is of particular interest in training because manufacturing and assembly falls into the category of mixed tasks, as there are both cognitive and physical requirements to be met to accomplish the goal. And to give you an example, for example, we have a multifunctional machine installation in the production line, which is capable of sharing, pressing, bending, etc. The process right now is that first the basic training is carried out before the system is installed. And then an external trainer carries out on-site training, which happens in parallel with regular production as the machine is installed. Following the completion of the on-site training, an assistance period of up to 6 months is required from the external trainer so that the plant can carry on by itself. And then at the beginning of the independent use, there are many alarms triggered, many machine stops, which lead to unplanned downtime. Also, often the moment where the production can start in full is overestimated by plant managers. So there is insufficient time for training, which only adds to the problem of downtime stops and alarms. And even then, when the process is changed, where the production changes, where the product changes, the errors increase again. And now this is also of particular interest. So as I mentioned, manufacturing and assembly is quite specific in the regard that it has the highest average number of hours for training per employee, but also the highest tendency for budget cuts on training. And to add to that, the current trends in manufacturing are that there is a high need for customability, customization of produced goods, flexible production lines. So the sector is constantly evolving. There is an increasing level of automation and robotization in manufacturing and assembly plants. There is also the transition from Industry 4.0, so automation and robotization, to Industry 5.0, where we want to have the worker as the center point and the main focus. So all of these aspects really add to the need for not only training of new employees, but also for reskilling and upskilling of the workforce that is already there. And this is where XR enhanced training in industrial applications can really flourish and can shine. So first of all, XR allows for faithful reproduction of real working environment and its specific challenges. So then both the new employees, unskilled employees, can face the challenges and make the mistakes in mistake-tolerant environment, but also there can be a faithful reproduction of more complex issues for the already skilled workers, which need upskilling or reskilling. Following on that, there is the reduced risk and costs in machinery and equipment operation, as all the mistakes can happen in the virtual or the extended environment and do not have a real impact on the production flow. It has also been proven that delivering training in XR reduces assembly time and error rates compared to traditional or baseline training in assembly and manufacturing. It shows better intermediate and long-term recall after training is completed, and such training interfaces can be available to the workers all the time. So not only when the training is scheduled for the new employees, but at any further point of their journey, of their employment career, the training can be adapted to any level and is still available for the worker. So now let me present the research projects that our department, robotics, is working on in that regard. First, we have guided collaboration with collaborative robots. So this is an assembly task where first the interface not only gives instructions on the assembly task, but we also have an AR digital twin, which helps the employee, the worker, anticipate the motions of the robot. Second, there are 3-tier safety zones, which you can see in the upper right corner. So green, yellow, and red. And this is really imperative for keeping the workers safe and also lowering anxiety levels. And here, third interface feature is the robot's trajectory indication. So it's sort of a lightweight version of the AR digital twin of the robot from the worker's perspective, as it also helps them anticipate and understand what is happening, what the robot is doing, what the robot is up to. A more complex solution for the issue of workers not knowing what the robot is doing, having high levels of anxiety around collaborative robots due to that lack of communication and lack of understanding, is this robotic skin interface, which uses flexible display technology. As you can see, a display is mounted on the robotic arm where information on robot status, task instructions, and also task status are displayed throughout task completion. And this really helps in improve the robot to human communication, which is a very challenging aspect of robot human collaboration. And here you can also see, indeed, if an error occurs, this is also communicated and handled. And now such interface results in decreased anxiety for the worker, in improved attitude towards the setup and towards collaborative robots, higher perceived enjoyment of the shared workspace and the shared task, but also, which is very important, increased intention to use. So improving robot to human communication and allowing the workers to understand what the robot is up to, what the task status is, what's happening from the robot's side, and training them with that additional help really helps the intention to use and the adoption of collaborative robotics in workplaces. A project with a focus on a different aspect of collaboration and robotic systems is our order for fulfillment study. So here we offer an augmented reality application which supports workers in order fulfillment, so in packing and checking. Now, this is important because we see the trend in automation and robotization of warehouses. There is also very sought after are solutions that provide even autonomous warehouses. But this doesn't mean that the human component will be out of the equation. So we really need ways to enhance and empower the human worker in such heavily automated or roboticized environments. Here, this interface is not only suitable for example, in-house logistics or warehouse applications, but it can also be used in quality assurance tasks. It can be easily repurposed for that, for quality assurance. And also the checklist components can be used in broader fields. So for assembly, disassembly instructions, for example. And finally, on a bit of a different note, one of our projects is focused on skill capture. So here, as you can see in the pictures on the right-hand side, tools are equipped with tracking markers. And also there is wearable gloves and caps for the skilled or experienced worker, so that his movements, his task performance can be captured. Now, why are we interested in skill capture? Well, first of all, there is a shortage of skilled workers. So by introducing this system, we can reproduce the motions of the worker with collaborative robots, with robotic arms, for example, and not to take over completely the job, but to support the workers. So taking over repetitive tasks, for example, and then being able to redirect the experienced workers towards tasks which require their analytical skills or their expertise. But in the training aspect, this is also skill preservation for future training. So such captured task performance can then be transferred to the robot, which then serves the purpose of teaching new employees how to perform the task. So we not only free up, for example, the experienced worker in that regard, but even in the absence of skilled workers in the workplace, the training can still be carried out with the hands-on practice and with the guidance from the robotic counterpart. Thank you for your attention, and I will now gladly answer any questions that you have.
Thank you very much, Alexander. I was wondering if there is any question. The presentation, thanks also for keeping the time and being on time. Usually, you need 7 seconds before anybody becomes bold to ask a question. And
hi, John.
Yes, please, Antonio. Yes.
May I?
Feel free to ask the question. Yeah, of course.
Okay. Thank you, Alexander, for this great presentation. Since I'm working on human factors, it is very pretty to understand how you measure the interfaces about human relations. So you present some measures like the attitudes, the easy to use, the perceived utility, and I don't remember, but can you present the graphics, please?
Yeah, of course. 1 second.
Okay, this. Yes.
Yes. Oh, these. Yes.
Yes.
So
About the
mhm.
anxiety, it's really interesting. So how you measure these dimensions?
This research and these dimensions were measured based on final evaluation after carrying out the experiment in an actual plant. There was about 40 workers that we surveyed their attitude towards both solutions. So working with a collaborative robot, performing the task without the interface and then with the interface. So yeah, the evaluation was based on the Godspeed questionnaire and also questionnaires like NASA TLX, though it was customized survey tailored to the specific use case. But yes, this is how we obtained these measures.
So you measure after the experimentation with the questionnaire, yes?
Yes, indeed,
How you
yes.
control the level of this anxiety after
Mhm.
and in the beginning? How you can explain this decrease of anxiety, for example? You have a level zero?
No, there is no level 0. As you can see, we start with 1, and but the explanation here is that so the baseline experiment is performing the task with a robot without the display. So the worker doesn't have the information what's going to happen now, what the robot is doing, why maybe it's stopping. And then in the orange with the OLED, this is the performing the task with the interface, so with that additional information. And this is all based on subjective on the subjective feeling of anxiety that the workers then gave a score of.
Yes. Okay. You think this is possible measuring time with sensors like eye tracking or heart pressure? You think this is possible?
Yes, it is possible. We also use, for example, such wristbands that record the vital parameters. So indeed, heartbeat rate, pressure, blood pressure, etc. So yes, it is also possible, and we do employ these measures in other experiments as well.
Okay. Thank you. Because in the project XR5, we are implementing these human factors measure in time. So you need more experience in this, but we are constructing a model, and this is very interesting. Your case study. Thank you and
Thank you.
congratulations.
Thank you.
Thank you, Alex. Before going to Fridolin, if you could give me a very short question, that sometimes we get from users. What new skills does the worker need to learn in order to use the immersive interface? So you need, understand the improvement in usability, the drop in anxiety, and so on.
Yes.
But as a worker, right? I still need to learn something new, right? To use the interface or not? It's not automatic. If you can give a short answer.
Yes. So, well, the shortest answer would be it depends. But of course, this is what we wanted to achieve with the display technology, is to really decrease the amount of new skills that would be necessary for the worker to achieve in order to benefit from the interface.
Okay, so maybe you need to learn something, but in terms of skills development, you need to learn less than.
Yes, that was the goal of introducing the display and the robotic skin interface indeed, yes. But of course, it's not the case, for example, in head-mounted displays. This takes some practice and this takes some assimilating to the technology.
Thank you very much, Alexander. I think we can move to the next speaker. Fridolin, the floor is yours to introduce yourself, your project, and we're going to hear about something really exciting, training astronauts. So please.
Now I just had to find the unmute button. Bardzo dziękuję, Alexander. Taki interesowany. Thank you. Thank you, John, for the kind words. I'm Friedland. I'm professor in AR/VR XR at the Open University, but I'm also a business person involved in spin-outs. I have the pleasure to talk to you today briefly about my lab and our spin-out company, then about what I call reality embedded learning, and then a few achievements, how far we have come with karate so far. I also thought I mentioned I'm not alone today. I have with me also Carlo Bizzi in the audience, who is our specialist, our chief learning officer, if you want, who will help me dodge the difficult questions that you might have about space later on. So briefly about my lab. This is the performance augmentation lab of the Institute of Educational Technology in the OU, the distance teaching university in the UK. We engage in sky thinking every now and then, having funny ideas, some of which are actually implementable that we prototype, which we then take forward to validation in innovation pilots. And we also maintain, and I'm the academic director of that, a accelerator program in which we collaborate with industry, like with our own spin-out companies or others, ultimately working towards bridging the dissociative gap between theory and practice, putting theory into practice. With karate, we are a fantastic team that we have pulled together, working on innovating training technologies for astronauts. But we also do this, I think, against the backdrop of the current wave of industrialization and AI, which we all know about and all hear about. And I thought it's a good point to pause briefly and look at this, what is actually happening there. With this provocative statement that I stole from the International Monetary Fund, which predicts that 40% of the current global employment is at risk, where it is very likely that the low earner jobs, the low skilled jobs, are the ones that are not benefiting in the same way as the higher income knowledge work jobs that we have. Which is likely to exacerbate the gap between, the income inequality gap between the winners and the losers of this industrial revolution if we don't pay close attention. We know that AI has good possibilities of outperforming, especially robotized work. Here you see a prediction of some colleagues of mine from down the road here in Oxford, where they predicted quite rightly that some of the jobs can be done by automation, can be done by robots, can be done by AI. We have self-driving trucks on the road, robots can fold your laundry, speech-based products and machine translation have now been a convenient reality for quite some time. Even if not all of the predictions have happened or have happened on the time frame the colleagues predicted, I do believe that most jobs continue to shift their occupational profile continuously, and if they are not shifting, then they're probably either too specialist to be affected by anything, or they're the jobs that are not going to improve. And maybe from that perspective also, it's an imperative that we have of replacing any job that makes humans act like robots. There's a certain risk, however, in the whole thing. And if we look at what Hamilton, William, and Hattie in their 2023 publication say about potential future scenarios, then we might as well end up in a fake work future scenario where we pretend as a sort of perverted human-machine interface to be in charge, while in reality we're not. Sounds scary? No. At the same time, it is clear that we have a greatest opportunity ever as a learning society. Here from our Open University Business Barometer that we co-publish with the British Chamber of Commerce, we see that 73 of organizations are currently facing skills shortage, 86% even if we look at large organizations. 42% of them, almost half of the organizations, say they have not filled roles because of the lack of skilled applicants, which results then in workload increases for the rest. And this gets worse when we look at more diverse criteria. So, for example, the share of older people in the workforce is not improving, and. So, greatest opportunity ever as a learning society. And who else could transport that change if not technology-enhanced learning, if not learning and training technology? And if you allow me there to look back a bit over the history of what we've achieved in the field over the decades, then maybe we see those 4 revolutions. The first wave, EdTech 1.0 with the digitization, the second wave, EdTech 2 with the web and the invention of the learning management system, which then naturally led to further improvements like personalization, individualization, where we have then personalized adaptive learning, such as Duolingo and other apps quite impressively demonstrate. Right now, we are in this wave of what I call embedded learning, EdTech 4.0, where we try to make use of XR, try to make use of wearable computing in different ways, maybe liberating finally users from being tied to their screens and putting learning out there in the real world. So what is that embedded learning in the real world? To me, it's symbolized in what you see here in this infographic. So we have a trainee who is about to learn something on a physical object, a machine maybe, learning with the help of an instructor or somebody beaming in remotely, learning with the help of specific delivery devices, wearable computing where already possible, mobile computing as a fallback while not, with holograms and digital twins. And that, if I unpick that, creates, I think, a different type of learning. It is really time for a new theory of learning, in my point of view, which circles very much around this idea of information versus its form. So if we look at this here briefly, information is regardless of form. So whether I say the train arrives at 5, my train is arriving later today at 5, the train is arriving, it doesn't matter which formulation I choose, they're all meaning the same thing. They all are equal with regards to the information they convey. And if I do that in a competence acquisition situation purposively, where the aim is to increase potential for future action, then we learn from information and we become more competent human beings. However, at the same time, we're not independent of what the form of presentation is, what the mnemonic form is, what cues are provided to help us with recall later when we need to make use of that information in practice. And there's a lot of evidence around that our memory system is actually sensory semantic and not just transfer memory model from working memory and so into a long-term storage and things like that. We know from a lot of psychological effects that the form can influence and trick us even into remembering something that wasn't even there. And if taken ad extremum, we do use the method of loci, for example, the memory palace, as the ancient Greeks would have called it, to help us recode and recall quite impressive amounts of information, as memory artists can demonstrate, remembering endlessly long sequences of numbers. So embedded learning is making use of this principle so that the form is not independent of the meaning, and the meaning is not independent of the form, especially when we do this as a means for learning. And that is what embedded learning is all about, trying to harvest the cognitive mechanisms to support learning in a better way. So maybe a quick comparison, embedded versus traditional learning. Embedded learning is about cued recall, about context, about switching representations, switching perspectives, curating our memories like other people curate their TikTok stream, spatial cognition, participation oriented, about learning by experience, learning by doing, embedded in practice. Whereas traditional learning is very much oriented towards the best representation, explicit, comprehensive, and absolute frame of reference learning, enabling things like multimedia learning, communication-oriented, conversational learning, and usually then also suffers of this ultimate inseparability of the learning space and the performance space, requiring some sort of dedicated classroom, rather taking people out of action rather than embedding it in practice. That's what it is. So what does it look like when we look at our promised area of astronaut training? We, in astronaut training, have to deal with a pretty extreme environment, as Carlo can tell you a story about. Astronaut training is not only up in space an issue, it of course is something on the ground as well, and also there requires typically globally dispersed teams to work together. When we look now at more distant missions, like going back to the moon in the next couple of years and in our lifetime to Mars, then communication isn't even available at times, like when the sun shifts in between Earth and Mars. There are 10 days of no communication at all, no direct communication, not to speak of the latency of 26 minutes or something. That is an issue, and at the same time, these missions get a lot more complicated if you can't quickly get back home, therefore requiring from the traditional 2 to 3 years for conducting something on the International Space Station to probably an estimated 6-7 years or so for some more deep space mission. This is challenging feasibility of any of these. This simply becomes too long. And therefore, we require generally a paradigm change in the way training is executed for space, meaning more flexibility, more autonomy, more real-time support in training, and then maybe later in execution locally as well. And of course, a better enterprise plan. So let me show you an outlook of what that looks like. And maybe I should switch the sound off so you can hear me speak. Karate, I think you anyways can't hear it. Yeah, that's good. Karate is training, preparing astronauts and ground personnel for these missions, which includes, of course, normal MAOR, maintenance, assembly, operations, and repair procedures, but also the much wider field of experiments, training the people who need to execute experiments up so that they can do that. We provide for that a collaborative solution where you can bring in an instructor in the authoring process of content creation, bringing together an otherwise dispersed team that usually does not meet in, however, a digital twin, so a realistic environment of what Columbus in this case here looks like, so that the content can be prepared for the astronauts in a much more simple way than with a lot of miscommunication, delays, waiting that is inevitable to regular communication via email or directly even via Teams or something similar. What we then also do is support the training itself so that instructors can be brought in on the fly, and that we can mix that with all other types of content delivery in our authoring tool and in our player to make these missions possible. One of these types that we have, one of these content types, has to do with AI. So there is a virtual instructor as well that supports learning where necessary. So highlighting three things of the work we do that we're particularly proud of is certainly the collaborative XR enhanced authoring, so that teams can work together that otherwise would have to travel for quite a long time. Bringing, for example, the payload engineer, the principal investigator of an experiment, the subject matter specialists from a vendor of a component, plus the astronaut trainer together, maybe even with additional media specialists or learning design specialists, voiceover artists, 3D artists, and so on. The second is certainly in the instructor support, so that there's possibility to link in instructors via a digital twin of the actual place into the real physical mock-up training, and providing the support with a sense of environment and an overview of where the trainee is stuck, plus the AI-enabled virtual instructor. And the last one, I also brought a small example. So this is here a public demo part. This is just a very simple LLM, but I'll show a few more things about the things that we do in the background. So don't know if you actually will hear something here. This is the authoring tool, configuring a prompt, restricting this to answering questions about the ISS. And now here is a question about opening the airlock. And you will
The airlock on the International Space Station can only be opened and operated by trained astronauts. The process of opening the airlock can...
Yeah, I'll cut it here because what she says is not important. This is just ChatGPT. We use that in a more complicated scenario. We have the possibility to interface directly with an LLM if we would need to, but we also have a RAG interface so that we can restrict answers to a knowledge base and deliver that then out in a more complicated virtual instructor setting where we use different modalities for input to orchestrate also between multiple instructors that may interact with you or with each other, to then communicate with an LLM and define also the outputs, how we're sending something out with facial expression and lip sync, and maybe what we do also AI path navigation to guide you to the right place. We've just evaluated the system and maybe a few insights from there. I'm happy to share a few scenarios generally that the astronauts identified. Maybe a highlight to pick is, of course, familiarization with hardware, but also then on the training itself that we can build performance feedback. This is important in various situations and is certainly a thing that is recognized widely as valuable. And maybe a second thing to pick, the evaluation feedback from the field trial that we ran with 12 participants with about 40% of Europe's astronaut trainers, which are 8 and an astronaut and some additional experts in XR. We could see that a system like ours has a lot of potential for preventing costly error, has the potential also to mitigate human error, can help with navigating the complexity of a training environment, could bridge that gap that I'm looking for as a researcher between theoretical knowledge and practical skills. And yeah, at the same time, through our field study now, we got a lot of feedback of how other parts of the system can be improved. So briefly, a summary. I think this shift happens from embodied cognition to embedded cognition, from embodied learning to embedded learning. And we will see more and more of that in the future, and we will increasingly understand how that works, how we can use cognitive mechanisms to cater for in learning situations, how we can support spatial learning, and what interaction modalities we need to build to support not only know how and know what, but also the know where, and using that also as a cognitive principle to help us learn anything. The sky's the limit. Thank you very much. And I am, of course, open to any questions.
Thank you very much, Professor. Is there any question to Fridolin? Very interesting presentation, by the way. You see this topic, at least personally, right? I'm not so much into it. So I was wondering, you know, what is the state of the art? I mean, I guess space agencies already use some XR technology, right, to test in microgravity conditions, right? Like scenarios between communication between astronaut and controller, or maintenance of a part, things like that, or not. So I think what's new here is the cognition part. I'm just wondering, right? I think that XR space agencies are users of XR technology, right? Already.
Of course, yeah. So like any other industry, you would have a lot of pilot examples demonstrating impressively what the benefits can be. And at the same time, I think overall the challenge is like in any other field of industrial training, that it's just not yet widely used. It's not used for everything. And when you train for everything, then you resort back to PDF or even worse, if you need be. So I think that's where the wider industry per se is. We are at that turning point where it can be put into everything, where we can build the interoperability, like through our tool, with the rest of the system landscape to create documentation of virtually anything and everything and execute that in XR. And I think space is there, no exception. It's pretty much the same as in any other industry. We're at a turning point where things could go big and wide, and not just have the impressive, shiny examples that have been demonstrated with so much effort in the past.
Thank you, Fridolin. I was wondering if there are any other questions. I don't see any questions in the chat or anyone being bold enough to ask something. If not, I would like to thank you once again. Please share with us a PDF copy of the presentation, so that we can something that we can share with the community. And I would like to give the floor to Harald and to Almer, XR 5.0 project. Floor is yours. Feel free to introduce yourself, Almer, your excellent company, and of course, your presentation. Thank you very much.
Sure. So thank you very much, and that we are allowed to participate here and actually present. And I'll just check. Do you see the presentation?
Yes, and
Perfect.
we can hear you very well as well. So please go on. Yes.
Super. So I would actually jump into and integrate what Alexander and actually already Fridolin showed or said, which is not much different than what we experience, even though the topic perhaps in some details might change. But the subject itself, I mean, me at Almer, let's say I build bridges between exactly the industry and the applications. And somewhat you can call it a strategic business enabler, and finding the right way actually to implement it. And then Fridolin said it at the end, right? I mean, Why would you fall back to PDF, and what is the way onwards? And I guess it gives the entry point to how does the AR technology need to look like to get accepted by users, and where is actually or the obstacle or somewhat the reference that people actually take the technology and implement it into the learning part, right? So today we're at a stance where we would be already absolutely in the future, right? Going onwards. So that's where all, let's say, started with the idea saying, okay, what if we use the human within the way towards there, right? Because at the end, it's still there where the strongest issues appear is actually how to actually bring the human together with the technology at hand. And augmented reality is a great way actually to tackle that. I mean, as you can see in that second image actually on that slide, it is nothing else than a head-up display as you experience on the car, to make it very simple, right? But at the same time, it presents really the information seamlessly, and you have actually not this feeling that it's actually, how to say, intrusive onto you. And to make it very tangible, that's how it looks, right? And if I wear it very simply like a ski goggle to really make it very humanized and actually usable, I just have it on the eye. I have the information. It quite looks cool actually at the same time. And I have actually my hands free and can actually interact. I can look through, look to the camera, look to the presentation, but I can also focus on the eye and see exactly the information I would have. And that's actually how it looks, just to give you a bit of the practicality. It's unfortunately only the laptop camera, which is not the best one, but it should paint you the picture. And from there on, I mean, we have assisted reality, augmented reality, mixed reality, and virtual reality. And our stance here is not to say one is better than the other. The question is, what is the most human way to interact with it while you're still in industrial application, while you're still in different use cases and out there, right, as a frontline worker, which at the end, there is an issue finding the right ones, training them, getting to them, how to transfer actually the entire knowledge, right? And then you have all the ESG goals and so on and so on. And we really experienced that actually having somewhat something in between, which is simple, which is robust, which is beautiful, which actually gives you that tackling of, okay, I want to wear it, you know, it's fine. I don't feel like it's something strange to me. Opens us the road. But then again, we see that actually we have obstacles, right? But at the same time, we have the remote assistance, which is very strong as a use case. And you can call it sometimes also a fire extinguisher. But at the same time, it's very practical and very useful in a day-to-day application when you want to train people, when you want to reach to people, and so on. And given that way, hardware itself is actually made very simple, as I actually showed you already in the practical example. But it is seamless. You have 3 buttons. You have one on and off. One is to navigate, but you can also speak to it. And the moment you speak, it acts. So you stay hands-free. You know that already from the YouTube videos or some engage with AI. So it's already familiar to many users to actually speak with something which is technological and just follows your voice, right? Might it be also Siri in an old way? And at the same time, you see the compact solution. It's lightweighted, and actually you have that most astonishing display. It's really not just a marketing gag, but the information is so clear that you can read it, right? And in worst case, that let's say you have glasses and so on, you can actually wear your glasses. Unfortunately, I only have sunglasses, right? But just to give you a bit the idea, if they would be corrected, you have your glasses, there is no issue. Just put them on, and there you go. It just goes seamlessly. So there is not any reluctance or something, right? And we build that really to endure to the pressure that you might have outside in all types of conditions, because the use cases are quite diverse, which we will go into it. And what you also see is all the technicality, which I described beforehand. So for the camera, it's a 25 megapixel camera, then you have powerful batteries, but we remain also very flexible actually. So if there is a special need, we can adapt certain things on the glasses itself, and to then really meet the customer demand, especially in logistics, is in that case actually one of the use cases which is very strong and needs that upskilling in that context, right? In combination with all the different technological tools already at hand. Might it be robotics, scanners, or just the old school way as PDF, as we heard, right? And Cablex is a very great example here to showcase you really one of the main use cases with service technicians. So you see that person is going up there, right? And what you do not have is actually, you don't want to have your mobile in your hand with your information, and you don't want to have a PDF in your hand. So you really need that hands-free way of working. And worst case, if it's not just a working solution where you have actually documentation or information on the glasses, you can also just say, call support, and then it actually reacts, and you can call the person you need, which might actually from the HQ support you as an expert. And all comes in one by just wearing it perfectly with the helmet, as in this example. The next example is actually with SFS Group. So these are Swiss-based companies, obviously, that actually also in the assembly line, or if you have something where you need to check within the industry, that's why the fire extinguisher I mentioned very early, you also have the possibility from site to site to work together, or if you need actually someone immediately because a machine is down, and that's very costly. And even though robots can handle a lot of things, but they can also have issues. So at the end, it is going to be a human who comes and check, right? And that's where actually the Alma brings all this expertise and simplicity just to the human, augmenting actually their reality with all the information they need at any time. And here I have a little example how it looks in logistics, which I mentioned before. So I hope this works properly with the video. So here you saw actually how this works together and how the display shows, right, in relation to the ERP system and everything integrated. Voila. But then we have the problem and the solution, right? So that's how it all started. So it was trying to find the solution to the problem and actually how to bring this all together. It started very small in the office, right? And you can see here a little video. So these were the first steps to get there, right? So how you can have that in such a clean and clear screen that actually you can have all the information at your hand, readable to any type. And that were the very beginnings with the helmet, which obviously has come out quite differently than it started. And I guess that's also a very important message here, also with the other speakers before. And it is evolving. You learn, and at the end, the human at the moment in the current present is still the one who applies the technology. And one should not forget that in many ways, right? And this is the reality you face when you are at the front with the industry and actually with the wishes to go very fast onwards in certain technological manners. And So if you see at Almer, Vuzix, and Microsoft HoloLens, right, these are the major players. You then see also here the different ways how everything goes. And to finish it actually with the focus, the key market verticals are really warehousing, logistics, retail, police, medicals, manufacturing, oil and gas and chemicals, right? Where a lot of robotics is also applied. Construction and mining, power utilities, and beverage and production, right? And automotive and after sales. And to finish it up, let's say to sum up, the innovation itself, if you look at it, that's where actually we positioned ourselves compared to others which have been in the market. And even though there is, let's say, a certain not immediate action on the augmented reality within the market, if you look combined with all the competitors which are in here, there is still an urgent need to somewhat have an application which involves the human together. And there we really believe that actually we fit the market narrative and actually that context very well together. And that's it on my side. So thank you very much for your attention. If there are any questions.
Thank you for the interesting presentation. I don't know if there are any questions. I think Jesus is always already ready for the next presentation, but two things, Harald, from my side. One thing is, how do you see the balance between the device being nice, right, being slim, and so on, and having enough compute capacity for doing things? Because you see a lot of products, okay, they are not nice, right, but they have a lot of compute capacity to run difficult scenarios, to run challenging scenarios. And then on the other hand, okay, it's nice to have something in your glasses, but then the things you can do is really not compute intensive, right? It's just some simple communication. So who defines the balance? And if there is space for both worlds in the market, not today, I mean the market that is coming. And also I have a second question, which is, excuse my ignorance, what is video streaming for influencers? Can you explain this application? It was, you know, on your top left bubble. It sounded very nice, but what is this?
So I mean, I will start from the back and work it up front in a quick manner to be in time. So that's actually what Alexander meant at the very beginning. So it's really on the fun part, on the retail, on the user part, right? Using stuff like that, video streaming or other applications in that influencing, right? You can have that with VR, with AR, and so on. So it was more meant in that context. And to the other question, which is a very relevant question, and Fridolin always said, already mentioned that in terms of learning, right? Where's the human limitation? And the human limitation is, for example, if you have something which has too much compute power, it also means at some point, right, you need to have a more heavier, more bulkier, but at the same time also the full vision, because you want to reflect more things. And the limitation of the human there comes in with nausea, with actually issues balancing actually the reality and actually where I am in the virtuality at some point. So having that approach with one eye still gives you actually one foot on the ground, to make it very simple, but the other one where you can navigate, right? It's like walking with your mobile, even though one should not do that in a train station, but you see where I'm going. It somewhat works, right? Because you still have the tangibility to the reality and you're not losing it. And that's actually where this comes perfectly together. Now it has its limitation too, right? Given certain, if you want to do anchoring, for example, spatial anchoring, you could not do that given the certain computing power, which then is limited. So we really take it to the first task which need to be done, which are relevant to the industry, as we listen very carefully, and that to deploy that already before moving onwards. But at some point, this will come, right? It's also a matter of chip, and it's a matter of other technological advantages. where we can implement this on the third model, for example, to answer your question, hopefully.
Thank you. For me, it's clear. Fridolin, you wanted to say something in this discussion. Yes, please.
Yeah, no,
Ask
I have
something, I don't
a
know.
question. So I anticipate it will be with glasses at some point in time, like with phones today. And that means that we are churning out a lot of these. We change them every 2 to 3 years to get the new model, and that creates a lot of waste. So I was wondering, what's your opinion on a modular strategy, or how do you see upgrading processes? How do you see recycling? Is there a circular economy that Almer is building around this in the future?
Very good question, and thank you for asking that, actually. So indeed, with our subscription model, we have actually, it's integrated that, let's say you have the Model 2, and then actually a Model 3 would come out. Now, can be next year, can be the year after. That depends actually on the market demand and how fast we technologically evolve. So that's actually the driver in there, let's say, how fast something new comes. But it's not going to be, it has to be something new. So that's not our stance here. Our stance is really, if there is a betterment, we can really improve and bring out. Otherwise, as I mentioned with the batteries, for example, we do ad hoc exchanges on already the current model. And that actually fits then certain demands, which gives us certain tailoring. And at the same time, when you have the Almer 2 and the 3 comes, we take back the Almer 2 and then we go back to the process. So we have a full fulfillment process actually, and also with the batches, which we really do ad hoc to the demand we have. So we navigate there a bit, and didn't have yet to come to any conclusion where we have an overproduction or anything, also on our size, right? I mean, we're not so old and so big yet. So it gives us also a lot of agility to react to that and be quite precise. And we also assemble it in Switzerland. So we still have a certain very close approach to it within the assembly and actually the refurbishing. Yeah. Thank you.
That's interesting discussion, but we have to move on. Thank you, Harald, with Jesus. Please,
Thank you very
the floor
much.
is yours. Feel free to introduce yourself and master and give your presentation.
Thank you. I'm sharing my screen. I hope you can see.
Yes, you can go on. You can see it. Thank you.
Okay. Good afternoon. Speaking here, Jesus Rosell from Mondragon Lingua Alecop, which is a partner of the master project team with a specialization in educational technology. The master project is about innovation, the teaching of robotics for manufacturing with XR technologies. So, well, I want to briefly discuss how educational approaches contribute to having impactful XR-based educational resources along with the technological process. But to this time, first, I will be providing an overview of the impact of XR on simulation and training. Secondly, I will give some guidelines about how the development of virtual environments should happen for supporting relevant learning outcomes in general training or educational frameworks. Finally, I will briefly use our master project as an illustration of the previous sections to some extent. Well, we have evolved as humans to use simulation as when we try to foresee something before it really happens. And from this to the pervasive artificial simulations that we use in almost every activity area, including training. A simulation is just the deployment of a model over time, run by a simulator. And as with any other system, mechanical or digital, we use interfaces to use the simulators and some engine hides in the system background that we call the simulation engine. We use simulation and simulators in training by several well-known reasons, like safety or availability of hardly accessible real resources. But the major one is that they are effective and efficient, meaning that they meet their intended training purposes, and at the same time, they save time and money. Saving time means shortening the practice time using the real resources, which can be problematic, and ultimately the time to the workplace. The simulators has a very few disadvantages. For example, some of them can be extremely expensive when high fidelity. Excuse me? Pero estoy ejecutando. ¿Y qué hago? Can you see these slides?
Yes, we can. It's not in presentation mode, but yes, we can see it.
But it's, yeah, it's.
I have this presentation in presentation mode. I don't know why you can see in presentation mode. I try again. Yeah. Yes. Dejar de compartir. Can you see in presentation mode?
No, it's still the PowerPoint application.
Okay. Ahí. Ventana.
Now
now?
it works.
Now
Yes,
it's
now
fine.
it's perfect.
Yes, now it's fine. Okay. Thank you. Okay. Well, I resume. I was talking about the simulators' disadvantages, which there are a few. For example, they're expensive. They can be expensive when high fidelity with the real system is required, such as in professional flight simulators, for example. Okay, in this slide, simulation and training adopts the XR technology. In brief, we use today most digital simulators that run powerful digital models that we call virtual environments in general. These models are controlled using proper software interfaces, which can put the user in the immersion spectrum. You know, in fully immersive simulation, the user gets a sense of presence, making abstraction of the real world, whereas in non-immersive ones, the virtual environment is experienced from outside by the participant. So we can affirm that the distinctive future of XR in simulation and training is based on affordability's potentiality of immersion. For example, highly realistic practice scenarios of valuable skills and at lower costs, etc. Being conscious that this full immersion is still the ideal, since it's dependent of XR technology status, but we know other grades of immersion can be perfectly practical. In addition, XR technology contributes to enhance simulation and training, solutions with more features that stem from capabilities of improved computing and networking and from existing evolved educational platforms. Here we can see the factors that are explaining the increasing use of XR in simulation and training, along with a set of advantages over more traditional simulators. On the side of factors, we find, of course, technological advancement. For example, highly promising are the simulation of virtual entities driven by artificial intelligence, such as highly effective virtual cognitive tutors or virtual collective entities to simulate sophisticated dynamic situational scenarios for practicing, for example, taking decisions, as in war games, for example, where enemies are needed that follow and adapt their own strategies and the like. Also, in the realm of interaction, think, for example, in the possibilities of gaze-based control enhanced. On the advantages side, we can see all the immersion learning benefits and others derived of improved computation and connectivity. It can be said that XR simulators, although still emerging in educational settings, are getting their place, overtaking the existing educational technology in some respects. Here we can see something like a case study, a reduced case study from the industry of flight simulators for civil aviation, for example, to pulse the current state of things regarding the XR technology adoption. On the left side, we can see the so-called full flight simulators. These are highly realistic simulators that represent the immediate pilot's practice stage before real flight experience with the aircraft. It happens that this is a very expensive educational technology, and of course, little flexible, but it is also a fully proven one, to the extent that it needs to be accredited by National Aviation Agency to be used by pilot training providers. This is also the case with other traditional simulators, namely the flight training device, FTD, which focus on specific avionics instruments or in mechanical system and parts of the aircraft. We can see on the right how the XR simulators are progressively being adopted, displacing or supplementing this FTD. Note, for example, note their main use currently and their lack of accreditation also often. We can expect from this example, from this case, we can expect that this trend in other sectors, especially where a high stakes training is involved, we can expect that this is what is really happening in other sectors. And in this section, these are some challenges to the adoption of this new educational technology, XR-based. Of course, a relevant one is fatigue, motion sickness, and the like. Hopefully, as technology progresses and the effects of on the well-being of prolonged work in virtual environments are better understood, they will be mitigated. Another important aspect is to ensure effectiveness and efficiency of the XR solutions in the light of available XR technology and budgets. If focused learning goals cannot be met in similar or better conditions that existing simulation technology does, then this XR solution should be reformulated. For example, modifying objectives or combining XR application with other training resources in hybrid training environments, etc. And this calls, of course, for several strategies, like a close work with stakeholders, buyers, end users, and the like, and also for a distinctive engineering where instructional criteria play a role in creating better aligned XR simulations. This is the subject of the next section. Now, this is just a basic representation of the process for developing systematically a virtual environment. We can distinguish here on the left a basic logic of activity with generic definition, building, and deployment stages. As in any other software project, during definition, the XR solution is specified. During building is designed and recursively prototyped and verified. And finally, during deployment, the final design is subject to formative evaluation and validation before delivery for use or exploitation. I will only focus on the initial activities where the XR simulation is specified with reference to some learning outcomes and associated strategies, typically pertaining to some larger training framework, such as a training program or a curriculum. This and the next slides are about some fundamentals. To specify any instructional development, some understanding of how learning happens is a must. Of course, this is a very complex process, all we know, with plenty of nuances due to the several intervening systems, but its fundamentals are clear enough. In essence, learning is transforming content or information into usable knowledge through an elaborative process of acquiring, retaining, and using. Using knowledge is synonymous with transferring the acquired knowledge in the educational setting to the real application context in an acceptable level, and it is the proof of training or education success. In turn, any training exists for essentially facilitating the process towards predetermined learning outcomes. From this framework, we want to ensure that our immersive virtual environments help in producing usable knowledge, being located in the teaching or learning process where they can contribute the most. This is a simple illustration of this last idea. Consider, for example, this elementary training case on the right. We can perfectly imagine a sophisticated virtual environment for practice where the seller trainee, in this case, serves simulated potential clients, answering their questions about cars that best fit their preference or needs before the purchasing decision, etc. Even offering them the chance of having a look at the cars accurately simulated with faithful, actionable models. This seems, of course, this is appealing and technologically feasible. Note, however, that this scenario only requires application of factual knowledge, which surely can be acquired and practiced using more traditional methods and more cost effectively. We can conclude that certain learning objectives, like less critical knowledge of a complete training framework, do not justify by themselves the development of still complex and costly XR solutions, although they can have, admittedly, they can have other values, promotional, experimental, and the like. Instead, XR simulations for training will be in principle, better oriented to promote complex learning. Complex learning, that is competencies, where different types of knowledge must be used, such as in solving the specific types of problems in a given work area or study domain. This is coherent with current approaches in education and training and materialize generically in problem, task, or scenario-based training programs or curricula. This is, of course, close to learning by doing approaches without implying completely exploratory environments or discovery learning, which are only effective approaches for most experienced learners. Instead, under these instructional approaches, learning organized around situational scenarios or tasks or projects that deploy progressively complex and realistic, along with supportive elements such as just-in-time knowledge or scaffolding. Even more critical knowledge required to deal with and to solve this type of tasks at hand can be acquired by other approaches and means, perhaps more traditionally. Okay, on this basis, to specify a virtual environment which is coherent with a scenario-based training, one initial step is to clarify the training framework. This is perhaps a tailor-made program for workers, an academic subject matter, or another case. We will want to identify potential training scenarios, those where, in general, relevant practicing is planned that resemble the real tasks of the workplace, or whichever be the application area of the acquired knowledge. On the left, and in the general case, we can see the tasks or competency of the real setting. Perhaps these have already been compiled in curricula or training reference. On the right, a representation of the planning approach to a generic training or education, like a course, etc., with several application levels. Scenarios, on the right, scenarios are properly identified at lowest levels, such as the lesson levels, since they represent the important part of the teaching strategy for attainment of focusing learning results or competencies. All this work needs to be done with training experts or instructional designers, perhaps the client themselves. This slide represents the next important step, which is the scenario evaluation and selection for XR simulation. In summary, the scenarios proposed as planned for training are examined from the point of view of technology and the logic of the virtual environment development, along with other constraints and priority of the project. First, at a global level, like on the left, for deciding if they can be simulated considering the type of scenario and activities involved, with what XR technology, to what extent, etc. And secondly, with much detail in each scenario to decide about the features and functionalities of the proper simulation, relevance, participants, interaction, feedback, mobility, tracking, point of view, etc. This is called a virtual task analysis, resulting in the selection and configuration basically of XR scenarios. Finally, this slide represents the concept design of each XR scenario with the sequences of activities at the user's experience, which is typically made through storyboarding or the like. There are no fixed rules in storyboarding. In the end, it's a useful tool to outline the deployment of the simulation, the user journey, the environments deployed, the key interaction, the immersive experience in a word. Through a detailed virtual task analysis, each type of scenario and activity or task included is analyzed in its requirements. We can go here into details, but it's easy to understand the important differences in approaching the diversity of scenario and tasks, the diversity of learning objectives in some, depending on their nature, physical activities, cognitive, situational, collaborative, etc. The required systematic is often a matter of experience and preferences of the expert project team. Well, finally, detailed specifications for the design of the virtual environments are produced, guiding the subsequent building and deployment stages. To end this presentation, I will give a glimpse of our master project. Master project, this is an applied research project oriented to foster precisely innovation in the field of teaching with XR technologies. Master stands for a mixed reality ecosystem for teaching robotics in manufacturing. And its main purpose is the creation of an open XR platform for delivering rich training content on robotics and manufacturing. The image represent the focus on robotics operators and modern robotics. The project responds to 4 technological objectives representing the research part, including the XR platform and 3 use cases. The common goal is to verify that advanced XR simulations are feasible on these fields. In addition, the master project has an educational objective, which is to develop and validate XR content for robotics derived from the use case or demonstrators. Master has also 2 open calls to expand both the research and educational objectives, helping the collaboration of SMEs. This is the basic architecture of the Master XR platform for creation, execution, and management of XR contents in advanced industrial robotics. In order to do so, the platform must incorporate the powerful simulation features derived from our research areas. In principle, this platform will be fully operational in training sectors, such as vocational schools, training companies, and the like, integrated with other management tools like learning management systems and others. These are our use cases in industrial robotics, or our technological or research objectives. In one area, in the first area on the left, we want to demonstrate simulation issues related to safety and ergonomics in robotic workplaces, especially those where operators work with collaborative robots. In a second area, the focus is on codeless programming techniques of collaborative robots using XR technologies. And in a third area, the goal is more general, and it has to do with gaze-based interaction techniques that can be used in virtual environments, including those for industrial training in general, like, for example, like robotics. This is really promising because it can free the participant hands to do other more critical interactions in the virtual environments. And here we can see the XR exchange or X scenarios that we have used originally in technological use case for research, prototyping, integration, and verification of simulation software functionalities. At the same time, they are the base for their improvement and recreation as potentially effective educational scenarios. This is in fact this is an example. This is the example of how each previous XR scenario are to be designed and deployed in an array of educational scenes representing associated tasks, problems, learning objectives in the end, associated with more integral ones or competencies. We are currently working on developing these sorts of XR scene and scenarios along with other supplementary content required for a pilot training. This XR content later in the project will have to be validated with end user trainees or students. Otra vez como antes.
Thank you, Jesus. I was wondering if there are any questions for Jesus as we move towards the last presentation. Are there any questions?
Yes, just to finish, I want to show a couple of videos here to finish.
Okay,
I hope
yes.
you can.
Sorry, I didn't understand that we were missing the videos. Yes, please, let's show the videos.
Yeah,
then,
yeah.
unless there are any questions, we can proceed with the Cortex presentation by Zach.
In this first video,
A valid plan has been successfully calculated.
Yeah, in this first
You need to
video,
share
a
your screen
collaborative
again,
robot.
Jesus.
Yeah? Excuse me?
Execute the plan.
Executing the plan path.
You're not sharing your screen.
Compartir. Share. Pantalla completa. Seleccionado. Seleccionado pantalla. Compartir. Comparte el audio. ¿No has compartido el audio?
¿Dónde?
Pero stop sharing. Otra vez. Share. Pantalla completa. Seleccionado. Compartir el audio también. Y selecciona. Era compartir. Y ahora la vídeo.
Can you see the videos now?
Yes, we can see the video, yes.
Yeah. Just to finish, in this first video, a collaborative robot is being programmed by demonstration using machine vision and voice control.
Plan a trajectory.
A valid plan has been successfully calculated.
Execute the plan.
Executing the plan path. The plan has been successfully executed.
Find centers of washers.
Looking for features in the image.
Move to the center number 2.
A valid plan has been successfully calculated.
Execute the plan.
Executing the plan path. The plan has been successfully executed.
Okay, this represents the feasibility of codeless programming and testing in a virtual environment without the real robot. The validated operation or movements will be the same for the real robot and tasks. In this second recording, a more elaborate educational scene related with safety in collaborative robotics. We can see here a realistic scenario, a guided task, mobility, a virtual assistant, cues and supplementary information for the user, and other features. Much features are being now added for improvement, including some gamification elements, etc.
Is this complete?
Yeah.
Thank
And
you, really
finally, in this video, some very brief demonstrations of the potentiality of gaze-based control enabled in virtual environments. For example, in navigating the scene and selecting objects, in using contextual menus, for example, with the gaze.
Jesus, if you want, I don't know if it's up to you and the master partners, we can also share some of the videos as part of the webinar. But I let you decide this, okay?
No, it's okay. This is the last.
Okay. No, I mean, if you want to share with the post-webinar material, right? Any of these videos, or if you have it there in some YouTube channel, please let us know.
Yeah. This was the excuse me. I go.
Thank you, Jesus, for a lot of
excuse me for the problems with the presentation. If you have any question.
Are there any questions? If not, let's move to the last presentation by Cortex. Jacques, please feel to share your presentation, introduce yourself, introduce your project. The floor is yours.
Okay, so can you see the slide? Okay. So, hello everyone and welcome. I'll be introducing you to an innovative platform that I hope will change the way we train people in industry, like healthcare, construction, and crisis management. So, Cortex is an extended reality platform that combines virtual reality, augmented reality, and AI to create an immersive training environment. This project was created by Alcatel with support from the European Union. Cortex Square comprises the 3 different pilots, but for today's presentation, we will focus especially on the VR training pilot, which is being developed by Actimat GmbH. This XR platform allows different device system and content format to work together, making it flexible and adaptable solution for collaborative training and simulation. Now let's move on to the VR training pilot, which is a core aspect of Cortex Square. This pilot is designed to create immersive and interactive training experiences where trainees can participate in both individual tutorials and share multiplayer activities. Trainees are assigned specifically training session where they learn through real-life scenarios, for example, in safe virtual spaces. Trainees manage this session using a PC application, ensuring that everyone receives the support they need. The goal is to encourage critical thinking, teamwork, and hand-on practice, which make training more effective and engaging for all participants. Cortex wouldn't be as effective without seamless communication. This is where Alcatel Rainbow API comes in. Cortex use the Rainbow API to enable real-time video, voice, and data communication. Through the use of WebArtist technology, trainers can communicate directly with trainees via video calls or chat. This feature adds a layer of collaboration that is essential for training. Trainees can also ask questions, get real-time feedback, and interact as if they were all in the same room. Let's now take a look what a trainer can do with Cortex. Trainers have complete control over the training experience through a dedicated patient application. They can assign a specific training session. You have video here. Trainer can also have communication tools like video calls and screen sharing, which allow them to guide trainees effectively through their learning journey. Trainers can even assign role in multiplayer scenarios, provide asymmetrical training experience that simulate real-life teamwork. And yeah. About the training overview, a trainee connect to Cortex Square using OpenXR compatible headset, which means they get to enjoy fully immersive and interactive experiences. Each trainee can access their assigned training session and tutorial, participate in multiplayer activities, and engage role-based scenario alongside other trainees. The use of real-time voice and video communication ensure that trainee can easily reach out of support and collaborate effectively with their peers. So you have a lobby here, and you can connect through Rainbow to access of your all of your course and scenarios. Cortex currently offers 3 training scenarios, 2 solo scenarios, and 1 multiplayer scenarios. These 3 scenarios are scenario templates, and there will be at least 10 scenarios available for the official launch in September 2025. The first solo scenarios is designed for the construction and industrial sector, where trainees learn how to move in VR and select the correct safety equipment for construction site. Yep. The second scenario involves a guided tour around the excavator, where trainees can learn about it before climbing on top and answering a quiz. And the first scenarios is multiplayer ones, focused on healthcare training. In these scenarios, trainees can learn how to respond to cardiac arrest, performing chest compression, using the defibrillator, and placing the defibrillator pads correctly. These scenarios offer practical hand-on learning experience in the virtual environment. To conclude, Cortex is an immersive extended reality platform that truly embodies the concept of reality-based learning in virtual reality for industrial training. By providing realistic and engaging training scenarios, Cortex helps industrial trainees to gain hand experience in the controlled virtual environment, which directly mirrors the challenge they may face in the real world. Using VR technology for industrial training offers significant benefits. Training can learn safety without the exposure to real-world risk, make mistakes without severe consequences, and practice repeatedly until they master their techniques. So thank you for listening. And yeah, I'm finished. If you have any question.
Thank you, Jacques, for a short but comprehensive presentation.
Yeah,
I
I
think
try
we
to
are
be quick.
just in time of the workshop, so we consume some time for the questions. Let me ask the participants, it's positive that we still have 30 people connecting. If they have any questions to Jacques, or if you think that we can conclude the workshop just in time. Are there any questions to Jacques and the Cortex project presentation? If not, I would suggest that we conclude the meeting. I would kindly ask the speakers that have not done so already to share with me their presentations, and we are going to share with all registered participants, but maybe with the community at large, your presentations and also other information, a brief summary of the workshop. Also, the recording of the meeting will be put in on the YouTube. So once this information is ready, I'm going to share with the project, with Master, with Cortex, OpenVerse, XR2Learn, of course, so that you can disseminate this information through your channel. In the meantime, I would like to thank very much all the speakers, but also all the people that attended this webinar, staying connected for 2 hours. Thank you very much. And yes, see you in the next webinar in approximately 2 months. We are going to share the topic promptly, and of course, the agenda for your consideration. Thank you, Yolanda. And thank you all for the continued support to this webinar's initiative.
Super, thank you very much.
Thank you.
On our
Bye-bye.
side.
Bye, thank you.
Bye.
Thank you.
Veronica, is there a question or? Okay. Maybe the hand was raised accidentally. Thank you.